Thank you. This is the last day of a very busy week for you all. Thank you for joining me for this very last session of your very long week. I hope it's been exciting for you and informative for you. So this session is on Cisco's SASE, approach to unifying networking, identity, and security. My name is Fei Ann Lee. I have been with Cisco for 20 some odd years now. My background is, came in from VPN, did network access control with ICE a few years ago. I decided to transition and kind of wanted to understand what was so hot about cloud networking or cloud in general. And so that got me into moving on the topic of Cisco Secure Access, or basically our cloud-based secure access solution. All right, so many of you are very familiar with ICE. So I'm going to go through an overview. For those of you who are not familiar with ICE, I'll go through it very quickly, and then I'm going to go into exactly what we can do with this identity, networking, and security combined together. Right? Then go into the configuration, and then follow that up with some demos. If you're like me, I can listen. I like presentations are great, but I need to go ahead and once I hear that, understand what's going on, I really do need to see things working together to be able to understand what, and appreciate it. So that's my focus this day, is to get to showing you, I've got 3 demos lined up for you all. And I'm going to focus on getting to those, and then welcome some questions along the way. But again, maybe save them off if you can to the demos, and we can go into details there. All right, so to kind of start off with an overview of the lay of the land, right? I mean, obviously today, right, post-COVID, the modern workplace has changed considerably. We've now, and then with the technology advancements, right, we've got users connecting from everywhere, applications deployed anywhere. And so with this, we've got this new security issue where we're trying to be able to protect our users from wherever they are to access the resources wherever those resources are deployed, right? So the complexity there is the applications, right? We've got the explosion from going from traditional on-prem environment to a remote access environment where we also have our applications no longer hosted in an on-prem data center, but they're also distributed in the cloud, right? We've got users and things, especially things these days, right? Being able to connect to the network and talk to the applications that they need to reach. So with all of this, it's getting very difficult to go ahead and securely ensure security for all of these different methods of communicating between users and their applications, and delivering that in a performant way. And so with that, we've got what Gartner has coined SASE, the Secure Access Service Edge, right? So that is a technology that combines both the networking and the security together, right? So if we think about it, right, we've got networking, laying the plumbing of how you're going to get from point A to point B, and then of course you need security there to go ahead and protect your users and things, as well as the data that's transferring across that network. So from the networking side, you've got that plumbing to get from point A to point B. You want it to be performant. You want some QoS maybe along with it. You want to be able to deploy that and that plumbing, if you will, seamlessly and easily. And we can do that with SD-WAN. On top of that, thinking about the security aspects, right? The security of services that you want to be able to employ, firewall capabilities, IPS inspection, web-based security. This user can go to Facebook, or this user cannot go to these news sites. That kind of level of security, as well as data loss prevention, right? These users are communicating and stuff. Who knows where they're uploading their information? Who knows if your corporate information is being compromised? You want to be able to protect your crown jewels, your assets, your information. Right? So data loss prevention and CASB capabilities as well. So networking and security gives you that protection for your users as they're trying to access their application, and Gartner calls that SASE. Now, Cisco's SASE is, again, SD-WAN with networking, networking with security. Security being our Cisco Secure Access, which is our SSE solution. And the networking part, Cisco being Cisco in terms of SD-WAN, right? We've got SD-WAN for all of your different use cases and your environment. So we've got FTD being able to do that, Meraki being able to support that, as well as Catalyst SD-WAN, right? So combining secure access with SD-WAN is Cisco's SASE solution. And this will be able to give you the ability to provide your single vendor security for this very hyper-distributed world that I was explaining, right? And then the tight integrations that we have between our Cisco products, Cisco SD-WAN, as well as Cisco Secure Access, will be able to give you that streamlined, secure connectivity to secure your modern workplace as your users are trying to access their applications from wherever they are and wherever those applications reside. Now, you've heard this past week a lot about universal ZTNA. And Cisco's universal ZTNA, the foundation of it, part of it, is Cisco SASE, right? Combining that networking and security together to deliver an outcome. But along with that, right, you've got networking connectivity, you want to deliver security, but how are you going to deliver security? What are you going to secure if you don't know what it is that's on you don't know what's on your network? Who is it that's on your network? What are the things are on your network? You need that identity, that context, to be able to build your policies. And that's where Cisco's universal ZTNA, right, is combining both the SASE component along with identity capabilities from Duo, Cisco Identity Intelligence, and Cisco ISE to give you that visibility of who and what is on your network. And with this, right, this is going to give you the capability of being able to see what's on your network, right? You can go ahead and use ISE to go ahead and authenticate and authorize the users on your network. ISE profiling will also give you visibility about the things that are on the network, right? And with that information, you can go ahead and protect your users and things with granular access control policies and segmentation. And then, along with that information, go ahead and with SD-WAN, be able to deliver a performant connectivity for those users trying to access those resources. Right? So you're able to see, protect, and perform. Now, with Cisco with identity, right? What are the outcomes that you're trying to deliver for your network? Right? One is comprehensive security coverage. You want to be able to secure those users and things, right? You need to have granular identity of those users and things on your network to write the right policies for the right set of users as they access the right set of applications, kind of giving you that ability to deliver security policies that are more least privileged access, right? You need to have more information about context about those things and users to deliver that least privileged access capability that you're trying to achieve with universal ZTNA. And then with all of this context that you're getting about your users and things, you'll be able to provide that right level of access. Now, with ICE, I'll go through this really quickly because many of you are familiar with this. With ICE, right, with its capabilities of being able to authenticate and authorize users on the network, as well as provide segmentation and access control, as well as get identity from identity providers, do MFA, identity providers like Okta and Azure, for example, as well as getting some more context from posture of the endpoints from mobile MDM providers as well, right? So you're able to get all of this context and information through the identity services engine. So this will give you the ability to go ahead and see what's on your network, the users, things, and applications, be able to secure it with access control policies and network segmentation. And then with all this context that you have about your users and things, share that information with other providers to be able to give you that end-to-end visibility of what you've got on your network. Now, I've been talking a lot about context, and so what is context-aware identity and why is it important? So as you can see on the left-hand side here, right? Traditionally, we talk about networking with IP addresses. As we know, IP addresses don't give you any context. You don't even know what that thing is. You just know it has an IP address. If you get more context about the thing that's on the network, like who it is, where is it coming from, when did it come into the network, so on and so forth, right? With all of this rich context, you'll be able to build more accurate, better, least privilege access controls for your users as they're trying to access those applications. Now, how do we get that context, right? So we've got multiple sources of context. We can get that from authenticating our users as they come on to remote access VPN, onto the wireless network, or using .1x technology, just authenticating the user, also taking advantage of ICE profiling capability, which is like fingerprinting the device that's coming onto the network. Those are sources of context. Our alliances that Cisco ICE has with our technology partners, like MDM vendors, and so forth. So those are ways of getting some context, as well as some capabilities that ICE has today with its latest release is being able to have integrations with different workloads, being able to pull context from cloud-based workloads. And I'll get into that a little later. Right? So all of these sources of context, if you share all that information into ICE, so ICE becomes your central repository of all this context of the users and things and applications that are on your network. You can go ahead and then leverage that information and build policies with ICE to go ahead and logically build like groups that you can use called SGTs to go ahead and build your policies for your network. Right, using this context. So like if you're a school, you get all the information from the school, you can take that information about the first graders, second graders, so on and so forth, faculty members, so on and so forth, all of that information, maybe you'll go ahead and logically bucket people into students, teachers, and so forth. And then leverage those groups, logical groups called SGTs, to build your access control policy and segmentation for your network using those logical group identities. Now with these identities, right, we have visibility about the things that we have on our network. If we go ahead and share that information, and we can share the information using APIs, PXGrid, or even PXGrid Cloud, right, which is a kind of like a framework, if you will. PXGrid Cloud is a cloud base, is an extension of PXGrid Cloud, which is a framework of sharing information in and out of ICE in a standard mechanism so that third parties can go ahead and leverage that information within ICE, either share in information to ICE or share out information from ICE to go ahead and get that same visibility of the users and things that they have on the network. And then when you share this information to other security components on the network, right, this is where you're going to be able to build a common identity of the users and things that you have on the network. So let's say we have a user that came in, they authenticated against ICE. This is a student. They're assigned the student tag. You share that identity of student with networking components, right? And so as that user is trying to reach applications, the network sees that user as a student and can enforce policy based on that common identity, if you will, that shared identity. That way you can get seamless and common policy, common enforcement across your network. Now diving into the use cases. All right, so this here, I'm going to lay the groundwork here. Cisco SD-WAN, remember we're talking about SASE, right? The networking piece is the SD-WAN, which does the connectivity, right? And so Cisco SD-WAN with Cisco Secure Access, what we have is the ability to automate tunnels from your SD-WAN branch into secure access. So each tunnel connection today will support 1 gig of throughput. When you're building these automated tunnel connections into Cisco Secure Access, what we do from the secure access perspective is provide you 2 data centers, connectivity to 2 data centers within the same region for failover and resiliency capabilities. So you get a primary and a secondary. With Cisco Catalyst SD-WAN, we can go ahead and nail up to 8 tunnels simultaneously to each data center to provide you an aggregate throughput of 8 gigs. Now moving on to talking about identity on the network. Right, so right now, the previous slide I was talking about the tunnel connections. We were able to bring up the tunnel connections. That's great, so now traffic can pass through. But we also would want to have some identity about that traffic to be able to build those least privileged, those more accurate security policies within secure access. So if we think about a Catalyst SD-WAN branch, typically an Catalyst SD-WAN branch is based on segmentation. Segmentation called VPN IDs, which are also like VRFs. So in the branch, you may have, as the slide shows, you have a segmentation there where you've got users over here segmented from the things on the network. So that logical segmentation, that VRF context, if you will, gives you some visibility in terms of what you've got on your network. You've got users and things in the branch, when those branches nail up the tunnel connections and the things in those branches are trying to leverage secure access to reach the applications, you'd like to carry that segmentation concept, that logical segmentation, that context, if you will, through to secure access. So if the users in the branch, the users from the user VRF in the branch is trying to access the internet, you can build a policy just for those users. Likewise, you can maintain the same type of segmentation for the things VRF as well. So now we're going to leverage the tunnel connections that we have built with secure access and be able to carry that context that based on VRF or VPN ID into secure access by marking the traffic with the VRF context in it. So the traffic will be passing through the network. This traffic came from the IoT VRF, for example, and then this other traffic is coming from the user VRF. Secure access sees that, and then you can leverage policies based on that information. We can take it one step further, because what we have with the context from VPN IDs or VRFs, those are what we call coarse-grained kind of segmentation. It's a big bucket of things, it's a big bucket of users, right? But within those segmentation areas, you have more, you've got more granularity that's in there. So of those users, you have students, you have faculty, for example. Things in that example there, you're in a manufacturing facility, you've got robots, so on and so forth, right? So not only do you need the context from maybe what segment they came on the network, but you'd like to be more specific about exactly what that thing is. And you can leverage ICE with SGTs to go ahead and get that granular context about the things on the network. And with that granular context, we also can leverage the tunnel connections that we have to share those SGT information, that granular context, within the tunnel connection as well. So now what we have with secure access is visibility not only about the network segment that they came from, but more specific context about that particular IP address, if you will, that's communicating through the tunnel. Now here's just a screenshot here of the packet format. So this is the tunnels that we are building from Catalyst SD-WAN. This is giving you a visual of what the packet looks like here. So we've modified the IPsec tunnel connection header to go ahead and include this metadata. And the metadata can carry the VPN ID as well as the SGT. I'm sorry?
Will that end up being multiple labels?
That'll be multiple labels within that. Okay. Within that header, yes. All right, and then, so this is the packet format for the SD-WAN side of the house. Moving into looking at a packet capture from within secure access. So this is what is coming in through the tunnel. And as you can see down here, from this Wireshark capture inside of secure access, what we're getting here is the VPN ID, in this case, which is 154, as well as SGT context from that traffic that's coming in from the tunnel connection. Now moving on to the something that's coming soon. So what I've been talking about, right, is carrying that context through the network or through the tunnel connections by enhancing the packet format to carry the identity with the network traffic, right? So that is one way of sharing the context and getting the context throughout the network. What I'm sharing here is something that's coming very soon, is the capability of just getting the traffic in based on IP address. And what we're doing with secure access is we're going to communicate with the identity services engine, which is where you had, as an administrator, gone ahead and created your policies to map the users and things and their IP addresses to SGTs. We're going to get, in secure access, the ability to get the association of the SGT, the context, and the associated IP address with that context. So that when traffic comes in through the tunnel, or any type of IP-based traffic, you can send any IP-based traffic into secure access. We'll do a lookup based on the IP address, get the associated SGT, and then be able to enforce policy based on that SGT context within secure access. So this means that it's just any IP address, any IP-based traffic. So it could be any Cisco product, or it could be a third-party vendor that you've established in an IPsec tunnel from the branch into secure access. And we can go ahead and take that IP-based traffic that's coming through the tunnel and associate it with an identity called an SGT, and then enforce policy based on that. This is just a screenshot here of what it looks like, what it will look like in the secure access dashboard. So here are the SGTs that secure access has received from the identity services engine. And these are the number of IP addresses that have been IP-based traffic that came in, and we've been able to correlate the traffic to the SGT. So then, for example, the top rule there is sales. There were 5 IP to SGT 5 mappings there. So those 5 IP addresses are now recognized as sales traffic. And secure access can enforce policy on those 5 IP addresses based on the identity of sales. Moving on to configuration. All right, so one of the things that we've done with the integration between Cisco SASE or SD-WAN and Cisco Secure Access, because it's Cisco on Cisco, what we've been able to do, as I mentioned before, is the seamless integration between the two products. So we've made it extremely easy to go ahead and be able to nail up these connections and share information across them. So here, in this first slide, what I'm showing here is the ability to go ahead and take those SGTs that have been created in ICE and share them into secure access, so that we now have a list of identities, if you will, to go ahead and leverage in the security policies that we build in secure access. Right? So the first step, very simple, 1, 2, 3. First step, go ahead and enable PX Grid Cloud and ICE. This is going to give ICE the ability to share its information from the on-prem, ICE server to the cloud. Secure Access will integrate with ICE to go ahead and pull in that information. And ultimately, when the connection is established, you get a status that it's connected and it's integrated. Okay. Now that we've got the SGTs in secure access, as I mentioned before, we want to use that context and leverage that in the access control policies that we build within Secure Access. So here, this is a screenshot here of showing the list of SGTs that we've received from the Identity Services Engine. We can see the list of them leveraging in the access control policies that we want to build. So we have a list here of the SGTs for the source of this particular rule or policy that I'm going to build to access internal or private resources within secure, going through Secure Access. And ultimately, once we get traffic through, in the activity log that we see within Secure Access, we'll get that visibility of the VPN context as well as the SGT context. So here, given this example here, I can tell that the traffic came in from the IoT VRF, and it was specifically from the Cell 1 devices in that particular VRF. Bringing in the SD-WAN context into it, right? How do we go ahead and connect the SD-WAN branch into Secure Access? This is an example of how Catalyst SD-WAN does it, right? First, we need to share the API keys. Yes?
So those tags
Yes.
from SGTs are taken from the context of what they source from when they connect authentication via ICE.
Yes.
So is Secure Access smart enough to know that if that device travels, say it was on-prem and now it's a VPN device, and say you've tagged it as a finance device or a finance user, that you created a tag-based policy, so now it's no longer on-prem, it's
Yes.
not getting sourced in SGT, but I created an SGT security policy in Secure Access. Now that device moves to at home or remote access. Can that SGT-based policy still be enforced because it's no longer getting a tag when it connects via home and not on-prem?
Thank you for the question. That's a great question. So what you're saying is the user got onto was in the branch or on-prem, got their SGT assignment,
Yep.
right? So now they're recognized as teacher, for example, right? Teacher goes home. How does Secure Access know that that teacher,
Yep.
that user is a teacher? Good question. So one of the things is, in order for that teacher from home, Secure Access has remote access VPN capabilities. So the user would establish a VPN connection directly into Secure Access. One of the things that you need to do is authenticate. Secure Access supports radius-based authentication as well as SAML authentication. Leveraging radius, ICE, we can pull in the authentication and the authorization that ICE is doing. As part of the authorization, it'll return the SGT. And so now that remote access VPN user is identified as teacher, and Secure Access has that visibility.
So ICE has essentially the ability to send SGTs not only to the campus or branch, but also to the users who are connecting on-prem from home or wherever they're coming.
Exactly. So as part of the authentication,
Based on their authentication attributes.
Based on their authentication attributes, right? So now that's achieving what that achieves, right, is a common identity, the same user identity, whether that user is at home or on-prem, and now that will enable you to be able to enable you to enforce the same consistent policy of whether that user was in the on-prem, in the office, or whether they were home as that user is trying to access the application. Okay? Moving on to this SD-WAN, right? And so what I'm showing here is This is a common way of nailing up the SD-WAN connection, building those tunnel connections. Very simply, to be able to share context, you're going to enable those two toggles there of sharing the VPN ID as well as the SGT. Yes?
When we connect secure access to Cloud PX Grid, is it subscribing just to tags based on sessions, or is it going to get the full SGT matrix so that I can have that visible to build policies, regardless of whether the session is tied to it?
Okay, so your question is, your question is the integration between secure access and ICE in terms of getting the SGT information, right?
Yeah, is it pulling, because based on what it's subscribing to, it can either just get whatever the sessions are and the tags associated, so that IP SGT mapping.
Mm-hmm.
But if I want to build policies, I want to know all the tags, regardless of whether there's an active IP type or not, so that when there is one, I can have a policy triggered, right?
Makes sense. All right, so what we do with secure access, the first thing we're doing is, as you were saying, right, you want to build policies based on this SGT context. So the first thing, in order to do that, you need to have the list of SGTs that you're working with, that you're going to build your policies with. So as part of the integration between secure access and ICE, we're pulling the entire list of SGTs from ICE to go ahead and leverage that information to build the policies. And then when traffic comes into secure access, we'll be able to do the enforcement, leveraging those SGT-based policies. Yes?
Are you planning to also let secure access assign SGTs instead of utilizing ICE in case of the previous question with the VPN?
Are we going to?
CDNA?
Is secure access going to be able to assign SGTs? So that is on the roadmap. Today, we're leveraging ICE as the central manager of all the SGT information. As we move forward, we'll be able to share, the SGTs back and forth bidirectionally. Right now, with secure access, we're just consuming the SGTs from ICE. All right, just FYI, this is just a snapshot of the configuration that you would do within SD-WAN to go ahead and enable SGT tagging through the tunnel connection. All right, so let me go ahead, and as I mentioned, I wanted to go ahead and show these demos to you. And so we're here now, which is great. All right, let's move forward. So the first demonstration I'm going to show here is the point that I'm showing here is just how seamless and easy it is to get the SGTs from ICE into secure access. ICE being an on-prem device, secure access being a cloud-based solution. So the first thing is to, from ICE, share the information into PX Grid Cloud. From there, any cloud integration will be able to consume the information, and then ultimately we'll share that information into secure access. So this is what it looks like. So I'm in ICE here. I'm going to enable the PX Grid Cloud integration. PX Grid Cloud is deployed in multiple regions. I'm going to pick the region that I want that's closest to me, US West. Go ahead and register. And so now what this is doing is uploading or making that connectivity, that connection between ICE and PX Grid Cloud so the data within ICE can be shared into the cloud. Here I'm in the cloud. I'm going to stitch that connection from PX Grid Cloud into secure access. What information do I want to share? I can share my SGTs, my trusted cape information, my session directory, so on and so forth. I can share all of that rich context from ICE if I want to. Today, right now, secure access is just consuming the SGT information. I'm on Cisco ICE, or on Secure Access right now. And then I'll establish my connection from Secure Access to PX Grid Cloud from this angle to go ahead and pull in the information, the SGT information. So very simple. Doesn't take more than 3 minutes to nail up that connection and get this information sharing between ICE and Secure Access. Yes?
So as far as you're making that connection to one region, what if you wanted to make that connection to multiple regions? Is that not a reasonable configuration, I guess?
I think it depends on your ICE deployment, how you're going to share your information into PX Grid Cloud, right? Typically, you could, what do you have in mind in terms of?
So if we have access points to Secure Access in
Yep.
6 places globally, replicating all of that data into a single region for Secure Access, what happens if that region of Secure Access goes down? We still have 5 other regions that we could communicate through Secure Access for. Is my data going to be there if I only replicate it to the one that's down?
So, okay, so you're thinking about connection from PX Grid to multiple regions just for redundancy purposes, right? Yeah, so today we just have, it's just a single cloud, but for the cloud to be down, it's an AWS-based service. It tends not to be down. But as we move forward, if you want to keep information localized in a particular region for, or country for compliance reasons, we will support that capability as we move forward.
Sorry, so you'd be able to support like 2 different ICE deployments, being rich? Because I have a customer that has a regional IC deployment, one in North America, one in Europe.
Right.
But if they wanted to use a single cloud instance for Secure Access, they could have both of them?
They could send both of them into the PX Grid Cloud, and then Secure Access would be able to pull the information from that repository of PX Grid Cloud. Yep. All right. Moving on. Sorry. Okay, moving on. So leveraging this slide once again, all right? So I'm going to use, this is a slide just to show you, to set up the demo that's coming next. So in this slide here, what we're showing is the segmentation. We're doing the VRF-based segmentation between users and IoT, and then the SGTs within those particular VRFs being shared across the tunnel connection into Secure Access to be able to go ahead and build policies. All right, so starting off here, looking at the context within ICE. So this is context that ICE has received from Cisco CyberVision, which is about this IoT-based environment, this manufacturing environment. So what we have here with this context from CyberVision is the fact that we've got a Rockwell device, and then the endpoint profile that it fits is cell 1. Is that playing? Yes, it is playing. Okay. Right. So as you can see here, we've got the IP address, a lot of rich context about that thing on the network. Here's the ICE identity logs. We can see that this device connected to the network was profiled as cell 1, and ultimately, based on the policies within Secure Access, assigned the cell 1 SGT. Now that we have the SGT, I'm looking at, this is the SD-WAN site, this is the branch. I've got 2 VPNs, or VRFs, if you will, 154 and 25. 154 happens to be the IoT VRF. Here I'm showing you that I've established how I'm configuring context sharing within SD-WAN, right? I'm enabling the SD-WAN to be able to carry traffic with the VPN as well as SGT context. And just visibility of truly the tunnel is up, and that context sharing capability between secure access and SD-WAN is working and enabled. Moving to secure access. As we can see here, with that connection, I've been able to, secure access has been able to learn about those VPNs, those VRFs. And if I go ahead and filter my rules here based on the ones that I've created with SGTs and VPN IDs, this is what our access control rules are. Looking at this, I'm going to drill into this particular rule for my IoT devices. And what I can see with this rule here is if you're a cell 1, an IoT device called cell 1, there's no reason why you should be going to the internet, going shopping, going to news sites, so on and so forth, right? And so that was the policy that we built within secure access. And now you can see in the secure access logs very clearly that in this case it's a robot, SGT, coming from the IoT VPN 154 was blocked from going to this particular site based on the data loss prevention policies configured within secure access, right? So now we've got that visibility of a thing trying to do wrong type of communication and being able to block it. Moving on to the next demo. So this is a demonstration that I'm going to show about applications. So I've talked a lot about getting context about the users and things on the network. What about classifying or getting context about the application and leveraging the, using about the application, identifying them as an SGT, and then building a policy based on that identity as well, especially for our cloud-based workloads. So in this example here, what I've been showing here is a specific feature that is new within ICE 3.4 patch 1. And its ability to leverage workload integrations, where here in this example here, I've got applications hosted in AWS. And those applications have been marked with these particular attributes, identified with these particular attributes within AWS. In ICE, of those AWS attributes, I'm only interested in the 4 name, IP, application, location as attributes or context for AWS applications that I want to build policy for. So what we're going to do with ICE is reach into AWS, get us information, leverage that information to go ahead and do a classification and map that application based on its IP to an SGT, and we can have both primary and secondary SGTs. Because as we know, everything doesn't have just one identity. We've got multiple identities, right? And depending on the policy that you're building, you want to know as much context to build it as you can to build the right policy, right? For here at Cisco Live, you can come in the building as long as you're wearing one of these, right? So this is my tag that I carry, right? And with this, I can come into the building, but these things here conceptually give me more granular visibility or context about me, and then that you can leverage this information to provide more granular access controls as well. So looking at this in ICE, this thing doesn't show the start button. So I can't tell if it's running or not. Okay, it's running. All right, so what I'm showing you here's ICE. We're going to go ahead and establish that connection into AWS for my example, but you can go ahead and leverage this to go ahead and make the connections into these other workload environments, such as Azure, ACI, so on and so forth, right? API keys, in order to give you the rights to be able to communicate with AWS, and leverage APIs to go ahead and ultimately pull in that context from AWS. So what we're showing here, here's my instance in AWS. It's been classified, these are the tags in AWS, name and role. In ICE, I'm going to build a dictionary where, okay, the name and role from AWS is going to be interesting to me in the way I want to classify my workloads in AWS. And so here, what we're looking at here is, pause this for a second, right? So I've built a classification rule. So my SGT for development servers is going to be based upon the AWS attributes name and role. So if the name contains a label of SGT demos and the role is identified as servers, those two criteria, if they are true, that workload gets associated and classified as a development server, SGT, and then I can use that development server SGT in the policies that I build for access control, user access to those particular development server applications hosted in AWS.
So how does ICE discover what the IP is associated with that? Is that coming from the cloud integration too?
So how does ICE discover the IP? That's part of the integration as well. So the API keys, you're being able to pull in all of that information, right? So in my example, I just use these particular two attributes, but you could go ahead and map them to an IP address as well. And so what you'll see, whoops, sorry. Is this demo moving? Go. Going through this again, sorry for that misclick there. I meant to pause, or rather continue. Okay. Again, showing you the API keys to go for ICE to get information from AWS. The attributes of the application hosted in AWS. I've got those particular tags created. We'll leverage those two specific tags in the classification that I'm going to build in ICE. Now that we have that classification rule built, the next thing is ICE communicating into AWS. And to your question about the IP addresses, this is where we're going to have is you get the visibility of all the IP addresses of those workloads in AWS, and they've now, based on that classification rule that we just saw, been mapped and classified to a development server. Yes?
So in this use case where you're tagging AWS apps,
Yes.
You create a user policy. Where's the enforcement point? Is it secure access that's enforcing the policy? The allow policy or the deny policy?
So this classification that we're doing in ICE, you could leverage that classification in any policy that you want that's being enforced either on-prem,
So like
on a switch, a router, TrustSec capabilities, right? What I'm specifically showing in this particular session is how it applies to SASE, and then secure access being the enforcement point. Okay, you could do enforce the same policy within your SD-WAN branch if you wanted to, if the SD-WAN device was communicating with ICE to get the SGTs. But what I'm showing here is specifically enforcement capabilities within secure access for the traffic that's coming into secure access. Yes?
Can you use STT tags as destination enforcement as well?
Yes, so that is, today, right now, it's just for source. Come October, with the IP to SGT mapping capability, we'll be able to support destination SGT. So you'll be able to have a complete policy or rule, source is SGT, destination is SGT, all being enforced in secure access. All right. Okay, any questions that we have? Okay. All right, wrapping up. All right, so I hope today what you've seen in this session is with the ability of SGTs and getting that context with SGTs and representing them with SGTs and VPN IDs, right? Is the ability to get comprehensive security coverage using those SGTs in that context and carrying that through the network as the user connects onto the network and exits through the cloud from end to end, right? And with this rich context, we're able to provide granular security control based on our, leveraging the information in our access control policies and our segmentation policies. And this is where we get that rich identity, rich context to leverage in the zero trust, least privilege policies that we want to build for our users as we move to a more ZTNA approach for the modern workforce. And with that, I thank you for attending today. Thank you for coming to this session. I hope it's been informative for you. Feel free, if you have any additional questions, to come up here. As always, you know the drill. Please fill out your session surveys. I'd really appreciate any feedback that you have. I'd love to be able to improve this session. If you have any suggestions, love to know how you felt about the content. This is the first time I've delivered this. This is a topic that is near and dear to me. So welcome your feedback. And again, thank you for coming. Enjoy the rest of the day.